Well, hi guys. Good afternoon, everyone. And welcome back for the 6th webinar in our series. And just like last week, we're mixing it up again. And so this time we've got a nice conversation about the competing demands for net zero buildings, but really putting the user at the front and center. And that's something which takes the whole industry to come together. So today we're really pleased to bring some new guests in for our webinar as well. So today we're going to welcome Mark Skelly and Thajnu Rashid from the Building Environment and Services Engineers at Skelly and Cooch. And then Luca Papaiz from high-tech developer and producer solar shading devices. I clearly haven't said my tongue twister this morning. Pellini Industry. So before we start, I'm Catherine Smale. I'm the marketing manager for Eckersley. And just a little quick note on the actual Livestorm software. So if you want to chat, then there's a little chat function over on your side. Say hello, kind of make them feel like they're not just speaking into a camera, as we all know that's kind of a hazard at the moment. There's a questions section, so if you want to ask a question, then put that into the box over there. And there's a little function whereby if you like the question, you can put a thumbs up on it. So that'll kind of automatically post them at the top, which is great. And also, there's going to be a poll. I've had a tip off, and there's going to be a poll. So along that section there, this is something new that we haven't done before. So have a look for the little poll section, and that'll be launched at some stage during the presentation. So watch out for that and get your fingers at the ready as if it was a nice game show. Okay, I'm going to hand you over to Alessandro. Oh, and I should say sorry, and also Alessandro and Camilla. Sorry guys. I'm so focused on getting the guests in there.
Yeah, it's okay, Kat, it's okay.
You're just as important, obviously. So Alessandro and Camilla, two of our associates in the facade engineering group at Eckersley. So I'll hand you over to Camilla and Alessandro. Thanks very much, guys.
Thank you, Kat. Thank you very much. And thanks for the introduction, and thanks also to our guests, Mark, Thajnu, and Luca for joining us today. It's actually counting up, it's 5 of us here, so it's 5 times the average people involved in a webinar at AUC. So what can possibly go wrong today? I don't know. Let's get started. Balanced transparency. So I'm sure that most of you today joining this webinar know that EOC are quite well known as the transparency, one of the most the highly experienced transparency experts in the industry today. We've been talking about extensively about design drivers, the technology development, and iconic projects that we managed to deliver, focusing very much on transparency and the minimalism of the detail and opening up the buildings to the outer environment. So we've been talking about that, especially there's quite an interesting webinar that you guys might have attended before. If not, I recommend you to have a look that our director, James O'Callaghan, gave last spring, talking about the challenges behind transparency. And then, and hopefully Kat will be able to send a link also in the chat for your benefit later. Talking about other webinars that we've done over the spring, just before the summer. There's also another quite interesting one, which is by Damien Rogan, our director of facade engineering, and his webinar was about facade design for net zero buildings. So someone might think that this is is like contrast with the transparency one, and in fact, if you remember, or I had trouble switching from slides. If you remember, one of his conclusion slides was that net zero is really important, and we should be all having a jointed effort in order to work towards net zero. But we shouldn't forget about good design for good buildings, because our ultimate goal is to deliver good buildings that are truly sustainable. They are truly engineered for the people that live in there.
Yes, Ale, indeed. Good buildings are generally those which are designed to embrace a sustainable approach. And as most of the audience will surely already be aware of, the UN identified a list of goals to develop a sustainable environment, and we at UC, like many others architectural and engineering companies, are very committed to implement these goals in our design and in the work that we do every day. However, these goals present a general approach that covers all aspects of sustainability. And not all of them are necessarily strictly related to the design of buildings. And in this regards, the World Green Building Council has recently published a diagram, literally a few days ago, which focuses on those UN goals which are related to the built environment and are focused on how these goals can be implemented when key players of the construction industry develop the design of the built environment. So as we see, they are very much focused on health and well-being. So it's not only related to a sustainable approach, broadly speaking, but this is very much connected to achieving good levels of health and well-being inside buildings. And we have been talking a lot about it recently together with our friends Skelly and Kuch, with Mark and Thajnu.
That's right. I mean, I hadn't seen this diagram before, and when I first saw it, I just thought it's another one of these diagrams that someone's created that, you know, tries to capture everything. We've all seen, there's quite a few of them around, aren't there? But the more I looked at it, the more I was pleased with, you know, the fact that health and well-being was at the centre of this, because the World Green Building Council is obviously, you know, under no illusions about the climate emergency and the fact that net zero carbon buildings is a key driver for everyone at the moment. And I think sometimes in the past we've tended to, when we have something like a key driver like net zero carbon buildings, to take our eye off other aspects of design. And you know, health and well-being is pretty key to why we design buildings in the first place. Obviously, you know, we've designed buildings to create shelter for people in which they can thrive. And throughout history, as we've developed building technology, we've been looking at how we can create more transparency, and a lot of that is to do with our connection with nature, the fact that daylight, sunlight has a really heavy influence on our health and well-being. We naturally want to be outside. And what we don't want with net zero is, particularly when we're looking particularly at timber buildings and, you know, the embodied energy and reducing embodied energy, to think that actually that connection with outside is a bad thing. And we need the challenge is how we achieve that health and well-being with the appropriate level of transparency.
Yeah, yes, indeed, Mark. And actually, talking about transparency, lots of recent researches actually showed how achieving a good level of daylight inside the building could have an important influence on health and well-being of people. And indeed, that's what we want to ask to our audience today in the polls that Kat just mentioned at the beginning. So we want to invite you to go to the polls tab on the right-hand side of your screen and choose one of the three answers about how much extra sleep may good daylight give to people. So how much gained minutes of sleep you can get when the building you're in is designed according to health and the well-being goals. So you're gonna have about the next 30 seconds to reply while we move to the to the next diagram, which is again
lots of people are already replying. So well done, guys.
Oh, okay, that's great. So we have a little bit of time to go through this diagram, which is again another diagram provided by the World Green Building Council, which explain like not only daylight but other features are very important to make a healthier and greener offices. So, for example, we see that thermal comfort or acoustic comfort or integration with the greenery are all parameters that are contributing to make our buildings better and healthier. And similarly, this can be applied also to other types of buildings, like residential buildings, hospitals, and the schools.
I think we got some results. It's quite a close match here, okay. And I think that the answer that wins by only 3 votes is 26 minutes.
Right. Okay. So
and it wins by 3 votes on the second one, which is 46 minutes.
Okay. So I think we are now ready to tell to our audience what the correct answer is.
It's 46 minutes, guys. So yeah, not the most of you have got the right answer, but 26 of you guys I got this right. So well done to the 26. But
yeah, it's almost the 46.
I wouldn't have got it right if I didn't know the answer.
I would have said 26 minutes.
Yeah,
anyway.
Probably me too.
Me too. 46 seems too much.
It's too much.
But, I mean,
but I was chatting the other day with you guys. If you remember, I would say, I mean, as a designer, I would be super proud of be able to gift 46 minutes to the people that are going to be living in or occupying the building that we are designing, right? So I think it should be quite highly motivational for us. Such statistic, I would say. So yeah. I mean, this is essentially allowing us to conclude that sustainable design, like a truly sustainable design, is a design that looks at people needs and is mainly done around people. So there's one interesting exercise that we've been doing is to come up a little bit along the lines of the diagrams that Green Building Council, the amazing graphics that the Green Building Council have put together to simplify this a little bit more and apply to a very geometrical shape as engineers typically would do. So as we all agree, we start from low energy design. So low carbon design, passive design, and like an effort towards tightening up the targets for the facades and for the building envelopes that we are designing. However, we quickly realized then this might be in contrast with a series of other competing demands, competing needs that deal with people and with people comfort, such as air quality and natural ventilation, such as thermal comfort, and obviously transparency and the daylight and the possibility of people to connect with the outside environment. So all of these seem to be slightly in contrast with the low energy design. And transparency and daylight as well can be seen slightly in contrast with visual comfort as well, because the more transparent, the more light gets in our building, the more risk you might have for your occupants there to suffering from glare and to suffer from visual comfort issues. And similarly, air quality and ventilation might be sometimes in contrast with acoustics. So to favor the air ingress within the building, you might encourage some more noise to get into the building, especially in busy cities. So all of these elements, all of these demands are quite concurring. And what we're trying to do as designers is to find a balance between all of these. Try to be in the middle, in this middle zone, this green middle zone, which takes into account the needs of the people, but as well as the energy side of it, and as well as therefore the net zero ambitions, and also the concepts of circular economy and all of the other requirements related to energy and embodied carbon that we have identified earlier. So we really like to be in this middle zone that helps us defining what the right balance should be for each of the projects.
Yeah, of course. It sounds quite easy, doesn't it? When you look at it in a diagram like that. But I think all of us know, as designers, it's not as simple as it appears. I mean, the sketch on the top left here, which I often refer to, and it's quite a well-known sketch. I'm sure people are probably bored of it, but I think it summarizes it pretty well. And it is a problem, that we've always faced as building designers. That sometimes the sun is our enemy and sometimes it is our friend, effectively. So, I mean, the sun is the giver of energy and life, and it's very important for net zero carbon to use that energy and capture it where we can, and not sort of reject it. And glass is a very good way of capturing energy. It's probably one of the most efficient technologies we've developed in the last 100 years at capturing energy, glass. So, the greenhouse effect, etc., etc. The diagram on the right, apologies for the complexity of it. It's probably not good on a presentation to put so many things on a slide, but this was something I produced about 20 years ago. I mean, my background, although I'm a building services engineer, my background is actually building environment and facades. Particularly, I spent a few years working at the Centre for Window and Cladding Technology, doing a PhD before I entered full-time into building services. So I've always had an interest in the building skin, and this diagram was really sort of developed at the start of my research to think about all the variables that affect what in those days was called intelligent facades, in inverted commas. And intelligent facades was sort of trying to push the technology to respond to a challenge that Mike Davis of Richard Rogers set out in 1981, which was, how can we create a building skin that is similar to the human skin, that is able to use technology to adapt itself and respond in terms of capturing energy, letting through air and obviously letting through light. So this diagram was really looking at that, and the more I looked into it, the more I realized that the user was really key to everything, because at that stage that we had quite a few examples of intelligent facades, but most of them were hated by people that actually were in the buildings. They didn't like those elements. So and a lot of that was because those facades were adjusting, and in terms of whether people are comfortable or not, the best definition of comfort I've found, because there's no set of conditions that everyone's comfortable at, is one by Mike Humphreys, which is comfort is the absence of discomfort, and discomfort is alleviated by making various adjustments. So, being able to make an adjustment, lower a blind, open a window, is very important for health and well-being, and user control is therefore very important in terms of net zero carbon.
I totally agree with you, Mark, on this. It's actually much easier to design a facade not considering users, because the problem comes when you start considering users is that this adaptive skin or dynamic skin, which in most cases, when it comes to fully glazed facade, the main actor of creating this facade dynamism is the solar shading. We start having and need to solve a trade-off on a dualism or an antagonism, which is basically user-based or automation. And this is something that is not an equation that can easily be solved. I can show you some pictures of projects that express this. This, for example, is a typical automated facade. FYI, just for people to understand what they are looking at, this is a micro blinds inside IGU. So they are lower than horizontal. So basically you see very well through, and they are all open. And this is, I mean, it creates a uniformity of facade, which might be pleasant for designers, and probably it's pleasant also for the people living in this building, because this is a sports center. But this approach not necessarily mean it's a good approach for other kind of projects. So same facade solution, but different space usage. So this is an office, and I like to talk about this topic showing Venetian blinds, because with Venetian blinds we don't have just a black or white of a roller blind, but we can appreciate also the shades of gray. And when we can do that, you can see that actually on the bottom left, what is a manual controlled facade, which basically is by definition the most user-centered. So the total control of the facade is given to the user. We see how this patchwork comes up. So this actually is defining how different is the requirements of each people behind those shading devices, closing them up, and I see the panel white, or opening them up horizontal, and I see it black or dark. But the thing is that if we consider this whole randomness, I mean, perfect randomness is pleasant, but the thing is that this is not the case. Actually, I on the top right, I can see sometimes where the thing gets slightly organized, but still slightly random. So, and this actually doesn't work also for offices. This works also for, I mean, this on the right, we see a residential tower in Tel Aviv. Same facade solution. In this case, blinds are motorized, but they don't have an automation, so they basically are manual controlled. Or in the right, this is another office with also the micro blinds, and you see this patchwork effect. So basically, looking at what people want on what's the image that a facade generates when people have control of the shading, and looking at it when a computer or an automation have control of the shading, this basically raises a question. So is turning the patchwork into a uniform facade acceptable? Those are two pictures of the same facade, just two different moments. So of course, the patchwork is by itself user-centered, and this is the so-called inside-out approach. And the other side, it's the building-centered, so it's the outside-in. But we have to define what we mean by building, because building might mean having a uniformity of facade to improve aesthetics, and so that the facade looks much more like the building rendering that I do on the design phase. But it might also mean users, plural, centered. So I'm trying to take the best guess considering a plurality of users, not a single one. Because when it comes to managing light, the thing gets a little bit more tricky, because light is basically a vector, so it has also a direction, and people are very sensitive to it in different ways, but they are facing different directions. So it's kind of a nasty job to find a correct solution. So when it comes to user control, we could switch to user control and full manual if we think that this is user-centered. The thing is that it's not actually perfect. It's a suboptimal situation, because users tend to be lazy on shading control. This means that they are really quick on closing shading when they have glare. But and this might be also good for G value. So the G value of the facade actually gets lower, provided that we don't need that solar gain. But it actually creates poor daylighting. So people actually forget to open shading when the glare situation has passed by. And this thing about poor daylighting is kind of subtle, because it's like having a waitress passing with a glass of fresh water through an office. Half of the people will take a glass and drink because they find themselves thirsty. This works even more for daylighting. People don't even know they are thirsty for daylighting. So basically, it's nice to have an automation that brings that a glass of daylighting for people to drink on. So this switches to, okay, user control is not perfect. Let's go to control logic, and we have to face the acceptance of the people living on the building, because it depends on a lot of factors. If we don't want the control logic to go into anarchy and then be turned off, first of all, it depends on how good is the automation guess. And I'd like to stress the word guess, because even though we have scientifically based decision on where to put a shading device, this doesn't mean that that position is correct. It's still a guess. It's like taking 1,000 people to the restaurant and making one single order for everyone and accepting that everyone will like that order because it's scientifically based. And this basically never happens, of course. Another aspect is how invasive is the automation. The more invasive the automation is, the more people will reject it. So it has to be subtle in a way. It depends on cultural factors, because Middle European people tend to accept more easily the fact that someone above have decided, had taken a decision for the sake of all. And this is something that doesn't happen much on Latin countries. I'm speaking as a Latin. I see a lot that control logics implemented in Germany or Austria tend to work, and the same control logic in a Latin country, let's talk about, I don't know, Italy, France, Brazil, they tend not to work. So we need to change it a little bit. And of course, the last thing, yeah.
Oh, sorry.
And of course, the last thing is the space usage. I mean, on a sports center, I can easily don't think about and don't care about glare much, or a hall of a building or a hotel. But of course, if I have to protect someone working on a computer, etc., it's going to be different. But most of all, when it comes to control logic, I'd like to stress the fact that even though we are in a way creating a uniformity of facade, most, or at least the most modern building certifications actually are requiring user override of shading position. So in a way, aesthetic uniformity is in any case in jeopardy. Don't want to say it's dead, but I mean, it's something that we have to face the fact that the facade will not be uniformed anymore. And this is, of course, not easy. And again, I don't think that the control logic of a facade needs to be the only one dealing with a facade. It makes much more sense to design a facade very well for the active part of the facade to be less demanded. So we demand less for it. So 50% of the work needs to be done on designing well a facade, orientating it well, making a good proportion between a good balance between transparent and opaque. Still, the moment that I have a transparent facade, this is a delicate point energetically speaking, comfort-wise speaking, and it makes sense to have a good improved control logic considering the user implemented.
Yeah,
I mean, I think this links quite nicely to that definition of comfort that I mentioned earlier, because it is difficult to say what's comfortable for everyone, and that definition, comfort is the absence of discomfort. Discomfort is alleviated by making adjustments is key, and I suppose when we're looking to reduce energy, sometimes those adjustments might not be useful for net zero, but they are useful for health and well-being. So I guess the challenge is how we really sort of try to make sure that the fixed envelope without all these adaptive elements is as good as it can be, so that we can reduce those interactions and the discomfort that promotes that interaction, as you gave the example of the blind lowering and lights coming on. I mean, this building is an extreme example of that in terms of its Fivitsu building. Some of you may be familiar with it, but it is an idealized example because we don't have that many sites where we can do everything from the, do all of the work from the roof. This is a single story building effectively, but it's an example of where we're trying to use as fewer materials as possible, to including a lack of blinds in this case, to create a fairly constant environment, and it's the old tried and tested vernacular of the sawtooth roof. as I say, is a pretty extreme example. So on this project, the brief was pretty challenging. It was for 1,000 lux on the working plane for the client. That's twice what you'd get in an office building, and he wanted that to be largely natural. And that put a lot of pressure on balancing overheating and heat loss, particularly in the space. And it was really a discussion between the client and us, of what was acceptable. And in the end, we sort of compromised on 1,000 lux for 72% of the year and 500 lux for 87% of the year. And I think he hadn't quite appreciated that daylight was such a variable thing, even on a north-facing elevation. So, I think that's important. But obviously, not all buildings have this element, and facades. Modeling facades and how to deal with facades is probably where the challenge is.
I think, Camilla, the mute is still on.
Oh, yeah, sorry. Yeah, thank you. Yeah, Mark, definitely. I mean, this is also something that we are experiencing since early stages of the design. So, I mean, we see that on this specific project, you have deeply analyzed the impact of the shape of the roof about the level of daylight inside of the building to a very high level of detail. But what we experience also from our side is that achieving good level of daylight is becoming more and more important, even from early stages of the design. For example, this is an office building we have worked on, and since the preliminary design, we started to look at parametric modeling to establish whether introducing a light well or playing a little bit with some geometric features like the glass to opaque ratio or, as I say, the introduction of a light well. We're going to have impact on the level of daylight on the typical office floor plate, and we see that this is happening more and more frequently, also at competition stage, in order to understand where the design sits to achieve maybe certifications about well-being, like BREEAM or the WELS certification. So it's something that's definitely one of the key drivers of the design at the moment.
Yeah, and I think, sorry, I think daylight is important, but sunlight, how to let sunlight into buildings is equally important. It's something that when we're concerned about overheating, it's something we sometimes try and shy away from as M&E consultants. But as a practice, we sort of see the benefits of sunlight. I mean, this project, which is also a Morrison Co project, Ortus, at the South London and Maudsley Hospital, was for a mental health charity, and it was all about how to maximize, how to demonstrate that the built environment can enhance mental health and well-being. And we spent a lot of time with the psychologists and psychiatrists coming up with a brief. And the big aspect of this project, which set the building form, was really the fact that we wanted to get sunlight into the building throughout the year. And we were on a north-facing slope, so that was quite a challenge. And it led to this stepped building form and this central space, which was a transition space where you could afford to let the sunlight in, and it helped drive the ventilation, drive the dynamicness of the space, and it was proved to be very successful and got great reviews from its users.
Yeah, and funny enough, from our side, we have recently worked on an hospital building based in Cyprus, so in Southern Europe, together with Amanda, the Veta Architects, and. On this project, the design was deeply focused on sunlight and on the well-being of the patients inside the building. Basically, the aim here was to maximize the transparency of the building envelope to achieve good quality of light, and also to incorporate maybe some greenery into the cavity behind the shading system. However, this was actually in contrast with other demands, and apologies, Mark, but in this project, the mechanical engineer really caused us some headaches, because they really needed to cut as much as possible the solar gains.
It wasn't Skelly and Cage, it wasn't.
No, it wasn't. But they really needed to cut as much as possible the solar gains going inside the building, as they wanted to use a passive cooling system incorporated in the ceiling. So that was a real challenge, and through the use of complex parametric modeling tools to estimate the contribution of the shading devices in limiting the solar gains, while allowing the views towards the outside, we collectively have been able to achieve a very transparent facade, a very transparent building envelope that also incorporate greenery into the cavity. So that was a great challenge. But yeah, working together with the rest of the team, we have been able to achieve this goal. That was based on the use of advanced parametric modeling tools, which is great, which is something that we are working on more and more often. But it's not always.
Yeah, and this is not just the only example, as you say, Camilla. I mean, we tend to implement these sort of studies in a number of projects, especially where complex shading elements are both an architectural feature, but also designed to bring the actual needed level of control of solar and daylight. So, I mean, just to mention just to show another few examples of what kind of facades we've been dealing with in the past, and we've been analyzing with these parametric tools, which are quite detailed. In your example, which was in Cyprus, is we proposed to the right hand side. But also the middle image is another project in the Middle East, and the left-hand side image is another project in the UK. But actually, the shading system represents the mortar joint that would exist in between brickwork, but instead of having brickwork, is all hollow. So, I mean, this brings to quite a fundamental question that we need to raise. We had to raise, and we are still investigating, carrying out more R&D on. Is how about implementing this within the whole building energy modeling, because whole building energy modeling by MEP engineers tends to be quite a simplified process, tends to simplify pretty much the shading elements to only perhaps linear elements, without the flexibility of taking into account all of those fancy arrangements that we've seen in the previous example. So I think one key project that we'd like to bring up today is because it's the result of a close collaboration that we've been doing with Thajnu and Skelly and Kuch as a joint effort between EOC and Skelly and Kuch, is an R&D project which exactly looked at how to simulate in a most efficient way, in a most simplified way, a complex shading system within a whole building energy modeling software. And Thajnu is going to outline roughly what the findings were. But if you're keen to know more about this, you should listen to Carmelo and Andrea in 2 weeks' time. They're going to give a webinar pretty focused on energy simulation. So.
Yeah. So this is one of the recent example of R&D work we did with EOC, and here we are testing different methods of modeling a fixed shading system with a complex geometry in IESVE and Energy Plus software. So here we were testing the capabilities, limitations, and accuracy of these modeling tools. So these kind of research work helps us to improve the modeling process and also understand each other's perspective of how we approach this problem. And also, it helps us to work in a more effective manner when we develop the optimum solution, in contrast to how we would achieve this if we were working in silos. So we are keen on continuing with such collaborative research work with EOC. Obviously, now for this webinar, I can't go into detail. So feel free to tune in on December 2nd, where Camilla goes through this. And regarding the modeling processes, when we assess facades and overheating studies, there is a tendency for space to be assessed as a whole, complete as a one single entity. But then in a highly glazed facade, it's important to assess the microclimate near glazing. So we were testing this scenario using the modeling tools we use. And in this case, we split a 6-meter zone into 3 separate 2-meter wide zones. And you can see on a warm week how the mean radiant temperatures in these 3 zones varies. Even though the dry resultant temperature is within the comfort range, due to high levels of mean radiant temperature, person sitting next to the facade could be uncomfortable. So we do a lot of these type of detailed analysis on projects. It differs from projects to projects, but it is helpful for the design team to take design decisions like adding thermal inertia onto the space or adding shading systems. So one of the options we tested here was the external louver system, which operates based on the incident solar radiation. And you can see here how the thermal asymmetry in the space could be mitigated through this approach.
And I think I have, there you go, a picture of this. This is something that I usually show on CPDs to give a real image to the concept that you were explaining, Thajnu, because people tend to look at the graphs and think that this is just math. But if you take a thermal camera and make a thermal scan of any kind of building with the facade being hit by the sun, you can see this really easily. I mean, those are 2 twin rooms. I took the picture and the thermography at the same moment. This is a university in Milan. And I mean, in one case, we had a really good glass. I mean, this is already a G37% high performance glass. And on the right, we had a high performance glass, but with a shading device, a louver in cutoff position, and that led to a 15% G value. The thing is that besides looking at the heat isle effect that we see on the left and not seeing the heat isle effect on the right, we have to consider that we don't have G value 0% on the right. The thing is that this 15%, it's much more distributed inside the room. And there's even an analogy between the daylight distribution and the temperature concentration and the solar gain concentration. So the moment that we find a way with the shape of my facade or the way I'm shading my facade to distribute daylight, I'm also finding a way of distributing solar gain, and this is of course good for radiation asymmetry, of course. The thing is that when I try to face these 2 situations and try to find a solution or a logic, sorry if I go back to the thing, but this is actually a dilemma, finding a balance between daylighting and solar heat gain. This is typical dilemma. I mean, when glare comes, glare basically dominates any kind of logic. But when we are basically dealing with daylighting and solar gain, which is basically what we are looking at, it's really hard to find a solution. So, for example, one approach that in Pellini we are taking, which is a quite advanced approach, is basically having an actuator for blinds that is doing some live ray tracing modeling and trying to imagine not only how much is the solar gain inside the room, but also what is the direction of the light transmission of that facade. And we basically position the people sitting behind that specific room, and we create scenarios depending, in this case, for example, the tilt angle of the louver, and through this ray tracing, we basically find what is the best trade-off between a solution. But as I was saying, it's not enough improving the automation guess with the real-time modeling. We need to put inside the loop the user as well. So if the scope is making a building where the user feels comfortable without having to intervene into the facade, we need not only to take a good picture of the sky and modeling and finding the best trade-off, but we need to let the user to correct the situation until he finds or she finds a wish scenario, a comfortable scenario, and then we need to retrofeedback this into the control so that the control next time it learns from it and creates a final bind configuration. I mean, this is by definition is not an equation that we can find the maximum and minimum. We should accept the fact that human beings are not perfect, are suboptimal, and any kind of logic dealing with human beings need to assess that and need to accept this thing that we are not all perfect and we don't behave the same way.
This is quite a complex concept, and all this control logic. It's quite I would say hardcore engineering that Luca and his team are doing.
Hardcore is the right word for it.
So I mean, we as we said earlier, we want to try to minimize this hardcore engineering bit.
Of course, I totally agree with you. I mean, this is the plan B. Plan A should be trying to make a facade, which I don't want to word the word passive, but probably it expresses what I want to say. So I have to make a facade which doesn't need active technology to solve the problem. We just need to use the active technology as a plan B, so that it does the complementary work to reach the 100% of the satisfaction. So
yeah, no, that's totally right. And in a way, it brings us back to our original question, which is, how do we find this balance point? How do we strike the balance for achieving truly sustainable buildings that are indeed designed for the people that live inside them? So
yeah, Ali, I think that at this point it's pretty much it's clear that striking this balance is a real challenge here, because there are so many competing demands trying to concur at the same time, and heading towards different directions, that our lives would be a way too easy if there was like a simple solution applicable to all projects. And I think, I mean, if you want to refer back to our original diagrams, I think that the solution sits inside the hexagon, and it's very much different for each project. So depending on the demands on a project specific basis, the shape of the polygon, the gray polygon inside the hexagon, is basically what represents the real solution for each project. So we can have a different shape every time we work on the design of a building. The aim, obviously, would be to try to reach the center as much as we can through the design of the facade and of the building envelopes connected with the contribution of the MEP services. But there is always going to be a gap between the solution of that we identify, so the gray polygon, and the ideal center of this diagram, where the perfect balance sits. And Luca, I really think that what helps to bridge this gap and to close this gap towards the center, aiming to get to the center as much as we can, is the implementation of adaptive solutions and active measures, as you were saying, which
totally.
should be considered as Plan B, but they really contribute to try to reach as much as possible that perfect balance that sits in the middle of the diagram.
Yeah, and this this balance, which is a jointed effort between what we can do as designers in collaboration with the other participants, other members of the design teams, such as MEP engineers, architects, and structural engineers, everyone that collaborates to a project in the early stages, needs to be jointed with the effort during the construction phase of technology providers, such as Pellini, that Luca is representing, in order to collectively come up with a coherent effort that brings all the different parties together in a collaborative sort of exercise that aims towards the center of this diagram. So I think that, you know, the takeaway of what we're trying to present today, and also the fact that we got 5 of us here debating, shows that you know, the real key to achieve as balanced solution as we can within all of this that we discussed today is to collaborate across all stages of the project and across really all disciplines as much as we can. So I think that's the end of the presentation. If we I think we very much over time, but unless there's some of our guests wanted to add anything else, but I'm sure that there'll be some questions, so we'll be going over some of the slides.
Absolutely. Well, let's have a look at the questions then. So I've popped back up again, but Andrea Botti asks, are there any studies supporting the idea of higher tolerance to glare when shading or glare controls devices are controlled by users versus when they're actually actuated by a centrally controlled by a BMS system? Could the adaptive comfort principles be migrated to a certain degree to visual comfort and glare?
I don't know you guys, if you know any study about it. I personally don't, but my experience...
I only know...
Yeah.
I only know a study about light levels, which was done, I think, in the 80s, from memory, which was looking at what's the right light level for people to read effectively. And there was one person in the study who was a complete outlier, who needed, you know, about 2,000 lux to see anything. And it turned out that person worked in a penthouse office. She was the secretary to the CEO, and she worked in basically a glass box on the 20th story. So she had adapted over a 20-year career to needing a lot more light than anyone else. So that's the only example of adaptive comfort in terms
but I
of
think
light,
that
I know of.
Andrea is actually asking if I'm not wrong, if users are more tolerant to glare if they are the ones in charge of the shading and glare protection control, if I get it right. Which indeed is something that I totally agree. To my experience, this is right. I participated to a lot of commissioning of shading automation. So you take a guess, right? So you basically try to model an automation, and then you put it in practice, and then you have to monitor it for 1 year, because in that case you have plenty of situations where people ask for corrections, etc. And on Latin countries especially, this is where I get most the corrections for override and override possibilities. And a typical situation is that people say that the automation causes glare and they are not able to override it. So usually you put a switch on the wall and you put it a little bit far away on the wall. This is the typical photocopy machine trick for people to not to spend time on or money on paper, and this seems to work. Not because people can go and override, but because the simple concept of having the possibility of doing it put the people in charge, and at the end this is what they wanted. So this is actually happens quite a lot on soft landing, for example, of the automation, which indeed it's very important for shading devices, because people need to understand why a shading is doing something, because the feedback for glare and light issues is very quick, but the feedback for temperature and energy consumption, it maybe even doesn't exist, or it's too slow for people to assimilate it.
To understand.
So
yeah.
when I try to do a soft landing for shading device, I try to explain a little bit this aspect and stress the fact that they are able to override. And the more I stress it, the less actually they use the override function. But I'm sorry, but I don't have any study supporting that.
Yeah, I was hoping you had some, Luca, but
I mean, the problem of industry is that we develop a lot of stuff, but we don't have the time to write and share about what we discover.
We can save it for the next webinar.
Okay.
So I have a question. So with all of these different softwares that you're clearly using between you, does it, how fluidly does the data actually move between the software? Kind of when I was an engineer back in the day, I mean, obviously things have moved on quite a lot since then, but, it was kind of very difficult to link up the different softwares between them. Are you kind of writing scripts to try and do that?
yeah, it's not fluid. It's not fluid.
As you have done in this webinar.
No, it's not fluid, and that's that's one of the biggest questions that we're trying to address with this R&D collaboration that we're doing with Thajnu and the Skelly and Couch team. Try to make the facade modeling talk directly to the energy modeling of the whole building, and that step at this point in time, unfortunately, is not fluid at all. Because of a number of limitations within the whole building energy modeling, and especially those ones that are accredited and can be used for certifications.
Yeah, we have certain tools to do compliance and certain tools for parametric modeling. We as services engineers, we try to model as accurately as possible, but instead of having
and in the end, what we're trying to do here is trying to close that so-called performance gap. So we want to try to be as accurate as possible in the whole building energy modeling, try to implement as much as possible what is the effort that we do on the facade engineering side and the MEP side.
Yeah, absolutely. I mean, it's going to be the nut to crack, isn't it, in terms of kind of moving everything forward when everything's kind of linked up. But on kind of linking things up, in terms of sort of when you've got obviously you guys are working very closely together, but in reality, kind of on lots of different projects, kind of is that, I suppose, for this to come together, you need everybody to work in very tight-knit collaboration. But is that actually possible on kind of most projects? Is it kind of, how could you set up projects to actually to be able to facilitate a better collaboration to make this go forward?
Through these discussions and also this R&D work, specific R&D work, we could understand a facade engineer's perspective. So that is quite important for us. Now we know what they mean by adding, calculating the coefficients, exact coefficients with the complex geometry, and what is the intention of the architect. So we at Skelly and Couch tend to work very closely within the design team. We are very open with conversations. That's the only way we can achieve.
It's useful having a facade engineer, certainly, because you don't often get facade engineers on projects. And I was thinking, when we were talking about doing this collaboration, about what's the difference between what I do and what the facade engineer does, and I summarized it as a facade engineer is invited, and I've got to be careful because I know a lot of architects are watching, but a facade engineer is invited by the architect to interfere with their facade, whereas quite often the MEP engineer is not invited to interfere with the facade, and you can sometimes. I mean, most of the architects we work with are pretty receptive to what we've got to say, but it's that understanding that if we get the building envelope right, we can get rid of the services. Really, the services are a fairly modern addition to buildings. We used to cope with buildings without services and energy for quite a number of years. So we need to get away from that. And I suppose as we've become more transparent, we've needed more energy to make things work, and it's how we keep that transparency, the health and well-being associated with that, but also minimize the services and the energy, and getting that envelope right is key. As an M&E engineer, I'd love to design a building without any M&E. It'd be fantastic. For that.
Who was it who said something to the effect of, it's like a good leader designs themselves out of the system, or something like that? They kind of, you know, it's a bit similar to that, isn't it? A good M&E designs themselves out of the building.
Yeah,
perhaps that's sort of a thing to take from that.
A bit like Luca wants to minimize the need for people interacting with the clever logic controls, right?
I mean, it's not me, it's a philosophy, I mean.
So, Wally, it sounds like we've got lots of work to do.
Do you think the lines are sort of blurring between the kind of the different disciplines in terms of who does what, and, you know, who takes responsibility for when you pass information between you, especially when you're, you know, trying to kind of group everybody together, or not group together, but work together more closely? You know, how do you take responsibility in that situation, the different parts?
Yeah, I think that's the challenge, is for people to maybe not just think inside their silos, but to have an interest in what everyone else is doing, to understand where they're coming from, and creating that true collaboration. And that, I think, particularly as facades are quite often contractor design elements, there tends to be a, you know, and you don't have a facade engineer, you know, there tends to be a pushing it down the road and not understanding. But it is such an important element to get right.
Sort of the fundamentality of it, or something to that effect, basically. Yeah, absolutely. Well, I mean, at EOC we do understand the importance of that, which is great. So it's kind of from that point of view, and everybody else, obviously, in the different processes that we're doing. Should we go back over to the questions? So I think we've got one more question from people here. So Casilla asks, if the user is in total control of the shading devices, how do you calculate the shading devices' contributions to the SHGC, or is it only used for glare control?
This is a question that it's quite complex to answer, because I mean, Mark and Thajnu, I talk a lot with service engineers about this, because it depends on the philosophy and how also the normative that you have to follow for the projects, I think, because some certifications and normative need for you to consider also the worst case scenario. Some clients accept or don't accept the fact that building might be overheating, for example, if people change the position of the shading device. So this is another concept that it's quite. I'm trying to soften the question for you, Mark and Thajnu,
okay.
but
I mean, one of the shortcomings of modelling, and particularly for compliance modelling, Part L, etc., is that the modelling forces you as an engineer to make an assumption that the user controls the building perfectly. So, for example, I know during the heating season, the user doesn't open the window, you know, that sort of thing. But in reality, they do, and that's why there is a performance gap, I guess, along with the fact that the modelling's not that accurate anyway. But yeah, I mean, the important thing is if we have designed the building to act passively without, you know, with fixed elements, then it is the user is only interacting when they feel that discomfort. And, you know, and if they're there, I mean, I think that's the control that Luca showed, that learns from people, is actually a key step in pulling together the fact that automated control is great for zero carbon and energy reduction, but manual control is great for health and well-being. And how do we get the two to marry up? And, you know, we do need technology, and building technology, if you know, is decades behind other technology, like the technology in your phone and all this sort of stuff. We need to you know, raise our game a bit.
Absolutely. Do you do any physical testing to sort of back up the modelling in that respect? Do you sort of take existing data from existing buildings that you've been working on and feed that back into the data, into the model?
we're trying to do. I mean, we've done quite a bit of post-occupancy stuff on Vitsu. We're trying to do more of that with self-funding that through our R&D tax rebate. We're reinvesting that in actually going back and looking at our buildings now, because we tried for a while to get the clients to buy that service, but it's quite difficult to sell.
It's so difficult, isn't it? Because they've got they've got what they've been given, so it's kind of there's very little incentive for them to do anything else with it, is it? It's kind of all about building those models to give the incentive to be able to feed back and improve for next time. But
physical modeling, Kat, is something that it's indeed related to the R&D that covers the jointed efforts between us trying to model as accurately as possible with our tools, and then compare our results to what the industry can actually achieve. So a potential future R&D study would be definitely to validate our modeling studies on blinds and shading devices against the real world scenario, when that blind that is modeled in 3D in the computer is actually built by the supplier and is tested directly.
Yeah, absolutely.
If we are working on refurbishment projects, we tend to go to site and assess how the building actually works then, and that feedbacks into our modeling process for that project. So refurbishment.
Yeah, that's a good point, right? Because we haven't covered refurbishments, but I mean, we did have a few examples, but there just wasn't time to cover them. But when we're looking at net zero, a lot of it is going to be refurbishment, in terms of taking buildings that are there, or the structure of buildings, and redoing them rather than knocking them down, because obviously there's a lot of embodied energy in the structure. So the facade, the envelope is key, improving that envelope.
Absolutely. It's I mean, you're opening up a whole new kind of ball game, I suppose, with the existing building challenge, aren't you? And how to because new buildings is a beautiful, exactly. So it's a beautiful new thing to just build up, and you can get everything perfect, whereas you're starting from an imperfect base to start with on the other one. So that's very tricky. Do we have time for one more question? Maha has asked, are these micro blinders inside IGUs, are they are the same in all parts of buildings, or does it differ from one to another? And what do they look like? Is it automated by devices or manual by user?
I don't want to talk about specific products, Maha, but
okay.
Yeah, usually the blinds are basically the same, but and usually each facade has if it's not manual, it has its own logic to change the behavior. I mean, the concept behind this is that very thin slats, if they are horizontal and or closed, they completely change the light behavior of the facade, and you basically have a dynamic thing going on. But I mean, I can come back to you with more information if you want.
That sounds good, and that sounds like a perfect time to wrap it up. Alessandro, you've been modelling some brilliant blinds behind you for a great backdrop for the presentation.
Look at this timber next to single glazed windows.
Oh my God!
Full of condensation.
So well done for doing that. I only noticed that halfway through. So. Right, in which case then, thank you very much indeed, guys. I'll bring this all to a close now, but I'd just like to say thank you, a huge thank you to our guest speakers, so Mark, Thajnu and Luca. It's much appreciated, and I think it's really important to show sort of the collaboration in the industry that that is required to actually to do something like this. And you can obviously see there's a tight bond between you, which is very useful and helpful in this situation. So a huge thanks for you giving up your time to do this with us today, and also to Camilla and Alessandro. Thank you very much for all the hard work you've put in for doing this, and I think it's paid off. When you said what could go wrong, I pulled it off, guys. I think it's worked. So well done.
Maybe that was on purpose. And thanks to you, Kat, for hosting.
It's brilliant.
Thanks a lot.
Thank you a lot. Thanks for having me, guys.
All good. Well done. Thank you very much indeed, guys, and have a lovely evening to everybody. And thank you very much for coming and watching us. Next week's presentation will be the Morpheus mistake. So if you can go and sign up on our website, if you want to come and join us for that, I think that'd be absolutely brilliant. So that's on same time, same place as it turns out in the UK. So one day I'll not be able to say that, but it's all good. So brilliant. Have a lovely evening, everybody, and take care, and we'll see you next week. Thank you very much indeed, guys.
Thank you.
Thank you, everyone.
Thank you.
Bye-bye.
Bye-bye.
Bye. Bye.